Welcome back to the deep dive. Okay, you've sent over this huge stack of sources, global memos, scientific papers, all these frantic startup updates. Today, we're really digging into, well, the frankly dizzying pace of AI advancement.
Yeah, that's a lot.
It really is. And it's not just tech anymore, is it? It's becoming this story about like massive physical buildings, politics, power, and also these kind of surprising ways researchers are finding to, I don't know, cheat physics, make things faster, cheaper.
That's a good way to put it. Yeah, the data we've got, it covers everything from, global funding battles and geopolitical friction right down to new features hitting your phone.
So what's our mission here with all this noise?
I think it's to understand two really critical shifts, and they seem almost contradictory at first glance. First, the true mind-boggling scale of the investment going into just the basic hardware.
Right?
And second, this really fast pivot towards efficiency, specialization, even smaller models in some cases.
Okay, let's start with the scale then, because the
Yes.
numbers are just, wow. They really define this race. We've got the Stargate project, that's OpenAI, Oracle, Nvidia teaming up.
Yep, that alliance.
And they're planning these massive dedicated AI data centers in the U.S. Sources mention New Mexico, Texas. What kind of money are we actually talking about here for just the groundwork?
The initial figures are just colossal, somewhere between, say, $400 billion and $500 billion.
Yeah, $1 trillion.
Potentially. And look, this isn't just building more server farms like we know them. This is about creating centers with, get this, 10 gigawatt capacity.
10 gigawatts. What does that even mean in real terms?
Well, to give you some perspective, that's enough electricity to power,
Yeah.
like a few million homes.
Yeah.
So the goal is pretty clear, right? Cement U.S. leadership. Build something so big, so advanced, that catching up becomes incredibly difficult for anyone else.
It really makes you think, though. If the entry fee is $500 billion just for the buildings and power, how fast do the people, the talent, need to run?
Oh, exactly. The sources show that race is just as fierce.
Yeah.
Yeah, absolutely. While they're pouring concrete for Stargate, the venture capital is flooding into the human side. You see, former OpenAI researchers, their new company, Applied Compute, they're apparently closing in on a $500 million raise.
$500 million for the people.
Right. And then Mira Murati, a key figure behind ChatGPT, she's started thinking machines. And guess who she's recruiting?
Let me guess. Core ChatGPT people.
Core ChatGPT creators, yeah. And the safety leads, too. It's like they're trying to literally capture the knowledge, the institutional memory, not just lease the best hardware.
So it's hardware and brainware. Let's look more at that physical footprint then. Beyond Stargate, the sheer compute power being planned is, well, stunning.
Yeah, we're seeing proposals for what you could almost call monuments to computing power, like the planned Colossus 2 supercomputer.
Colossus, too.
Yeah, the specs are kind of nuts. Over 500,000 GPUs.
Huh.
And it's projected to draw 1.21 gigawatts when it's running full tilt.
1.2 gigawatts just for one machine.
And at the same time, Nvidia isn't just scaling up traditional stuff. They're pushing hard into quantum. They've got CRGQ, DGX quantum systems, even opening dedicated quantum centers. The ambition seems to be dominating both AI now and whatever quantum compute looks like next.
Okay, so as this physical footprint explodes, it's obviously becoming a geopolitical thing, a battleground.
Inevitably.
And policy is reacting fast. We're not just talking technical limits anymore. This is national strategy, control.
Precisely. And policy is hardening incredibly quickly. Look at China. They've barred their big tech firms from buying the latest Nvidia chips.
Right, trying to cut off access to that top-tier compute for the biggest models.
Exactly. And on the flip side, the U.S. has been really explicit, rejecting calls for centralized global AI governance. They're emphasizing open innovation, competition, but very much within their own sphere.
And you see these interesting strategic plays, almost like lobbying. XAI opening up its frontier models to all U.S. federal agencies at super low cost.
Yeah, that's a fascinating move. You embed your tech early with government agencies.
So they get used to your stack.
Right, and maybe more importantly, you get early insights into what regulators want, what data they need. It creates this powerful feedback loop.
But connecting that back to the global competition, the sources point out a really interesting split in priorities.
Oh, yeah.
While the U.S. seems focused on AI leadership through these huge language models and massive compute, China apparently has a 5x lead in factory robotics.
Wow, 5x. That suggests China's heavily prioritizing embodied AI, systems that actually do things in the physical world.
Rather than just chatting or processing text.
Exactly. Maybe less focus on the general conversational AI the big U.S. labs are chasing, more on robots on the factory floor.
That is a really crucial difference in focus. And even within the US system, there's that tension you mentioned, proprietary versus open.
Right. Even as these frontier models, so the really big ones, seem to be getting more locked down, more proprietary.
Like Stargate.
Yeah, potentially. But at the same time, Nvidia is flagged as a leading open source contributor in the US. Hundreds of releases on Hugging Face. And Google's doing its part, opening up huge public datasets via its Data Commons MCP server for developers.
So it's like two tracks running side by side.
It seems like it. You've got the $500 billion closed labs pushing the absolute boundary, and then this really vibrant open ecosystem building on shared models and data. Both are maturing fast.
Okay, so now let's pivot, because this is maybe the most surprising bit in the entire deep dive. We've just talked about Stargate, $500 billion, suggesting every new model has to be bigger, hungrier for power.
Right, that's the assumption.
But the data suggests something else entirely, an efficiency paradox.
It's honestly the biggest shocker in these sources. The updates are suggesting that OpenAI's GPT-5, well, it reportedly used less total compute than GPT 4.5.
Wait, less? How?
Apparently, they achieved this by massively scaling the post-training phase, but starting from a smaller base model. It's about scaling smart, not just raw size.
Hold on. If the next generation of the world's top model is using less compute, does that undermine the whole argument for needing a $500 billion Stargate? Is the hardware kind of obsolete before the concrete's even dry?
That's the $1 million or $500 billion question, isn't it? But I don't think they're mutually exclusive. You might still need that massive scale, the Stargate level investment,
Right.
to get the initial breakthrough to create that foundational model.
Okay.
But then these efficiency tools, that's what makes it actually feasible economically to deploy and use these things everywhere else.
Ah, okay. Which brings us right to those lean methods making waves, things like DSPy, GEPA.
Yeah, these tools are kind of revolutionary.
Yeah.
Because they're getting results that previously needed these massive, expensive training runs, but they're doing it at a fraction of the cost. It feels like developers are shifting from just throwing more GPUs at the problem to using smarter frameworks for training and deployment.
And this drive for efficiency leads straight to more specialized tools, right? The
Right.
rise of, what are the sources calling them? Nano models?
Exactly. Liquid AI, that's an MIT spinoff. They're really pushing this idea. Hyper-agile, task-specific AIs, designed to completely reshape what they call agentic AI.
Okay, just to make sure everyone's on the same page. Agentic AI means systems that don't just, like, answer one question, but proactively handle complex stuff for you. Manage your digital life, maybe?
Precisely that. Multi-step tasks, taking initiative. And maybe the best consumer example of these specialized nano models is that nano banana thing.
Nano banana. Seriously, I mean, the name alone probably explains why it went viral.
It'll definitely help. But the tech is solid. It swaps photo backgrounds, removes objects effortlessly, and it's apparently going straight into Google Photos.
Wow, okay. That's massive consumer reach for a specialized, efficient tool.
Noli.
And beyond photo editing, we're seeing huge specialization in embodied reasoning.
Yes, embodied reasoning systems built specifically to understand and navigate a world. Could be simulated, could be physical,
Right.
like Google's Gemini Robotics ER 1.5 purpose-built for robotics tasks.
Making robots smarter about the real world.
Exactly. And DeepMind took their huge Genie 3 world model and essentially shrunk it into something called Tiny Worlds. It's a compact model that can generate playable game environments on the fly. They're building systems that get space, physics, interaction.
And purely on the software side, coding AI is getting way smarter too.
Oh, yeah. Meta unveiled a new 32 billion parameter open-weight code world model. It focuses not just on writing code, but on understanding its deep structure, its semantics, even simulating how it might run. That's a new level.
Wow.
And for efficiency. Qwen 3 Coder 30B showed really strong coding performance, but running effectively on just a single GPU.
So this specialization, it's pushing performance way beyond just general smarts. It's hitting expert levels.
Absolutely. Look at Anthropic's Claude Opus 4.1. They claim it achieves 95% of human expert performance across, 44 different white-collar...
90%.
That's the claim. And GPT-5, based on this GDP Val benchmark, is apparently hitting expert level in over 40% of industry-relevant tasks. We're watching AI cross this major threshold in professional competence, which makes AI agents suddenly seem very essential.
Okay, that high competence leads us perfectly into how AI is shifting. From being just a reactive tool, you ask, it answers to something more proactive, an assistant.
That's the key transition happening in consumer AI right now. OpenAI's Pulse features may be the prime example. For Pro subscribers, it starts pulling together your schedule, emails, to-do lists into a personalized daily digest.
So ChatGPT becomes less of a chatbot, more of a helper.
A full-featured proactive helper, exactly. Though, the sources rightly flag the privacy issues there, giving one system access to all that intimate data.
Yeah, that's a big concern. But we're already seeing agents take over real-world tasks, like that AI mode restaurant booking for labs users in the US.
But maybe the biggest integration is happening in the digital plumbing we use every single day. Well, look at Google putting Gemini AI right into the Chrome browser. A dedicated Gemini button, AI features in the address bar, even back-end scam detection. AI isn't just a bolt-on feature. It's becoming like the core operating system for how you experience the web.
And they're building creative tools, too. Google's Mixboard for making images with Gemini.
Yeah, custom image creation, brainstorming. Meanwhile, Meta is reportedly talking to Google about using Gemini models to improve their ad targeting.
So these big models are becoming the new utility layer that other giants plug into.
Seems like it. And even governments are using this stuff. The UK government apparently recovered over 480 million as in fraud, mostly COVID relief scams using advanced AI tech.
Really? How?
AI is just incredibly good at sifting through enormous data sets and spotting patterns, anomalies, things that look like fraud, way faster than humans can.
So all this automation agents, managing schedules, booking things, handling money stuff, it's pushing the industry towards building this agentic internet.
That's the term floating around. Yeah. And if AI agents are going to handle everyday digital tasks and transactions for us, well, they need their own way to pay each other reliably, without waiting for human approval.
Oh, okay. Makes sense.
Which is why you see things like Cloudflare introducing NetDollar. It's a stablecoin specifically designed for secure automated payments between AI agents. You need dedicated financial plumbing for an agent economy.
But, okay, the more we automate, the bigger the security risks, right? We need a serious reality check here.
Oh, absolutely. The sources highlight some, frankly, terrifying vulnerabilities linked directly to this automation push. Take the force lead vulnerability in Salesforce's Agentforce.
What happened there?
It was a flaw that exposed sensitive customer data, CRM data, through something called indirect prompt injection. Basically, the system built to help manage customer relationships became a vector for leaking their data.
Yikes. That's a direct hit on enterprise data. What about risks in just building these models?
Well, remember the Neon Call recording app? They had to shut down completely after a security breach exposed user recordings.
Oof.
It really highlights the risks involved in just getting the training data these specialized models need. Sometimes the rush for data compromises basic security.
Which explains why security companies are scrambling. Okta is debuting tools specifically to secure not just human identities, but also non-human identities.
Meaning the AI agents themselves.
Exactly. Security is shifting. It's not just about protecting you, the user. It's about protecting these autonomous software agents that are acting on your behalf.
It's a really high-stakes race. Building the capability versus securing the capability.
Okay, let's try and bring this back to the listener then. We started with these two big, almost competing forces. The sheer scale and cost of Stargate, and then these rapid, specialized efficiency gains, nanomodels, DSPy. What does this mashup mean for the tech you actually use day to day?
I think the relevance is immediate and total. Almost every piece of tech you touch is being fundamentally rewritten right now under the hood. You see it directly in your web browser with Chrome getting Gemini.
Right.
And you see it in really critical areas like healthcare. Systems like TAT-CHFM are already using foundation models, analyzing medical records to flag high-risk cancer patients much earlier. It's a complete platform shift, powered by both those $500 billion bets and these smart, efficient software tricks.
Okay, so here's the final tension our source material leaves us grappling with. And it's a really provocative thought, I think. It's the clash between all this computational need and the environmental cost.
Ah, yes.
The sources mention that AI video generation tools, they use dramatically more energy as the video gets longer. Even short clips can apparently use as much power as some household appliances running for an hour.
That's right. It's incredibly energy intensive.
So given these plans for massive 10-gigawatt data centers like Stargate, all dedicated to accelerating AI, maybe even towards superintelligence, what happens? What happens when that massive ambition for compute slams into the reality of a growing, maybe unsustainable carbon footprint?
That's the biggest unanswered question hanging over all of this, isn't it? That fundamental tension between the computational scale we seem to need or want and the environmental cost. That's the challenge we're all going to be facing increasingly in the years ahead.
A really crucial point to end on. Thanks for walking us through all that.
My pleasure.
And thank you for joining us for this deep dive. We'll see you next time.